Alright, as you can see, my first set of numbers is 32, 18, and 42. Alright, now what I'd like you to remember is how do you find a list of prime factors that these numbers are created from? And that's going to take us back to the idea of factor trees. So in this space down here, next to my other example, we're going to break apart each number, and hope you can read that. That's 32, and I think of what can multiply to give me 32. Now there's lots of combinations. There's certain strategies that work for less writing, but let's just pick 4 times 8. Okay, then I ask myself all the time at this level, can I break those numbers apart anymore? Yes, I can. 4 can be made up of 2 times 2. Now it just so happens that each of those are prime numbers, and so I'd like to circle those. Those are the end of my roots or my branches. That's why we call it a factor tree. Now look at 8. 8 is what? 2 times 4, and if you can tell, that's a 2. 4 can be broken up one more step, and that would be 2 times 2. Alright, now I take a look at all of my circled factors, and notice that it's 2, 2, 2, 2, 2. So there's 5 2's. I need to write all of them. Okay, I'm going to use a multiplication dot here. And so it's going to be 2 times 2 times 2 times 2 times 2. 5 2's multiplied together. If I do multiply those together, yes, that will give me 32, and that's the way we check. Alright, 18 is going to be a little bit easier. Let's take a look over here. 18 is, of course, 9 times 2. It's supposed to be a 9. And 2, of course, is a prime number, but a 9 is not. It's 3 times 3. And both of those do happen to be prime. So if I put them in order, smallest to greatest, 2 times 3 times 3. 2 times 3 times 3. Alright, and as you do this more often, you can get pretty good pretty fast. You may not even have to draw your prime factor tree. 42, let's take a look here. 42 is 6 times 7. That's one way to make it. There are other ways, but I'm going to go with 6 times 7. 7, yep, that's a prime number. And 6 is 2 times 3, and both of those are prime. Alright, put it back in order on my list. 2 times 3 times 7. Alright, I'm going to change colors here a little bit. And then in red, what I'm going to do is I'm going to look at my prime factor lists, and I'm going to circle all the groups of factors that are in every list. So here I have a set of 2's. I'm going to write that off to the side. And then I have a 2, but a 3 and a 3. Nope, it has to be in every list. Is there anything else that goes in to my answer? Turns out that the largest number that goes into, largest factor that goes into all 3 at the same time is 2. Greatest factor, common factor of 2. Alright, now I want you to hit pause on this video and look down here at the other 3 numbers, 30, 75, and 45. Do the same thing. Make a prime factor tree and list of prime factors and find the common ones and figure it out. Go ahead and try that. Alright, now we're going to take a look at these 3 numbers down here and find their greatest common factor. And this technique again is called using prime factors. So one way to get the prime factors of any number is to make a prime factor tree or a factor tree. And as you can see up here, what we're going to do is break the numbers apart, and all I need to do is think of any 2 numbers that multiply to give me, in this case, 30. So I'm thinking 5 times 6. Now 5 cannot be broken up any longer. In other words, it's a prime number, so I'm going to circle it. It's at the end of the root or the branch. 6 is not prime, so I can do 2 times 3. Now when I circle those, I'm done. All my branches are done, or roots if you want to think of them. And I have a 5, 2, and a 3. I want to put them in order down here on my list. And when I do that, it's a list of factors. So remember that factors multiply to give you another answer. So test it. 2 times 3 is 6. 6 times 5 is 30. That's just another way to break apart 30. So 75 is my next number. And how about 5 times 15? Okay? Or you can even do 25 times 3. Believe it or not, the result will be the same when I'm all done. But if I do 5 times 15, 5 is prime, 15 is not. 15 is going to be 5 times 3. So those are prime. all of my branches are done, and I have 5 times 5 times 3, but let's put it in order. 3 times 5 times 5. Okay, I better make that looking like a 5. And 15 times 5 is 75, or even 5 times 5 is 25. 25 times 3. Doesn't matter what order you do it. Now over here I have 45, and I'm thinking that that's 9 times 5. 5 is prime, but 9 can be broken up one more step, and that would be 3 times 3. So all my prime factors are done at the end of my branches, and it's 3, 3, and 5. So let's put it on our list. 45 is actually made and created by taking 3 times 3 times 5. That's a list of its prime factors. Alright, now I'm going to change colors here. And now the trick is to look at the common factors, because we're talking about greatest common factor, and this is a vertical process. I see a 2 here, but I don't see 2's in either of those lists. I'm looking for any number that happens to be in all 3 lists at the same time. And I notice that there's a set of 3's in all 3 numbers, so I'm going to write my 3 down over here. And there's also a set of 5's. Now it doesn't really matter whether I choose that 5 or that 5, but it has to be in all 3 lists at the same time. So I'm going to go ahead and make kind of another list here of all of my common factors. There's a set of 3's and a set of 5's. So my final answer multiplied together now is 15. Now what that means, of course, is 15 is the largest factor of all 3 numbers. Those 3 numbers can be divided by 15, and that's the largest number that's possible for. Alright, so you're going to make a prime factor list and do some circling of the common factors and multiply the result together. Alright, hope that makes sense, and good luck.